Great. So this video is for chapter 2, and it's going to cover drawing the production possibilities frontier. Economics classes use a lot of graphs. This is going to be the first graph that we introduce. And the production possibilities frontier is really valuable in illustrating the idea of trade-offs and letting us see see opportunity costs. It's also very helpful in helping us visualize what would be feasible in society versus what's infeasible. And that's an important element of economic reasoning, is we want to make sure we're comparing things that are actually possible in the world as opposed to comparing things that are possible with things that are impossible simply because reality wouldn't permit it. So the production possibilities frontier is going to show for a very simplified economy. What we'll assume here is that we have an economy in which we have two goods that are being produced that people are going to want to consume. That's obviously a gross simplification, but when we draw graphs, we want to have two dimensions. And for our graphs, that means two axes. That means we can have two variables on the axes. And so for the production possibilities frontier, it's nice to be able to look at a graph here where we'd have two goods. So I've picked oranges and wheat as a couple of goods. The names here are actually completely irrelevant. The idea is that there are two goods, we have resources in society, and they could go toward producing one good or the other. Now, the production possibilities frontier is going to graph out here something that's a hypothetical. So we're going to, in effect, go through this in a hypothetical fashion. And what if, and then that would give us a point. So we're going to start here. I want to mention this. As I said, we use a lot of graphs in economics, and the first thing you should do anytime you see a new graph being introduced is to look and see what variables go on the axes. And for our production possibilities frontier, we're looking at an economy and a trade-off producing two different goods. So we have quantities of the two different goods on the axes. In this case, again, for concreteness, I picked oranges and wheat. So what we would do here is let's conduct the following hypothetical experiment. We take all of our resources in society, but remember, we live in a world of scarcity. So we have limited resources. So we know how many people there are. We know how much land there is for cultivating oranges or wheat. We have a certain number of tractors and other resources. We have all of these resources, and we could use them to produce either oranges or wheat. And the PPF is going to graphically display these options. So let's consider the following hypothetical. We take all of those resources and say, let's produce nothing but wheat. We're going to produce only wheat. Grow wheat everywhere, including like in Florida or everywhere. We're going to be trying to grow nothing but wheat using all of our available resources and technology. So let's imagine how many bushels of wheat might we be able to grow. Well, whatever that number is, it'd be a big number. I don't know what it would be. And to some extent, when we're drawing a graph like this, the exact number doesn't matter. It doesn't matter if it's the 32 million bushels or 32 billion bushels. It's going to be some number. And whatever that number that would be, we would come up here and start graphing the PPF by putting a point on the wheat axis. And so this would be the quantity. This would be the quantity of wheat we're producing if we use all of our resources to producing wheat. And then, of course, if we're using all the resources to produce wheat, well, oranges have to be produced. So if there are no resources being devoted to growing oranges, the quantity of oranges we must have would be 0. So that gives us this point here, all wheat and no oranges. Now let's do the opposite hypothetical. Imagine we took all the available resources out there, given our technology and our available resources, and we put everything into producing oranges, and only oranges. How many bushels of oranges might we be able to grow? Well, it's a big number, I'm sure, and it doesn't really matter what the exact number is, but it is some number. And whatever number that would be, that would give us a quantity of oranges. And of course, if we're using all the resources to grow oranges, we can't be producing any wheat. So the quantity of wheat we would get in this case would be 0. And we would end up having some point here on the x-axis. That would be, again, the quantity of oranges we could produce when we put all of the resources into producing oranges and none into producing wheat. Now, we could go through and think about different combinations here in the middle. We think about putting some of the resources into growing wheat and some into growing oranges, and maybe half of the resources into growing wheat, half into growing oranges, and so forth. And we would get a bunch of other points. In fact, we get enough points that we could imagine, and we'll, for simplification, we'll do it this way. We'll imagine we can actually draw a nice smooth curve. So it would just be a bunch of points in here. We can draw some kind of a curve. Now, I drew this curve so it's got sort of like a boat shape. A second thing you should start to think about when you encounter any graph, and then start to look at the curves or lines that are drawn on that. You want to say, does the shape or slope of this curve or line tell us anything of economic significance? And the production possibilities frontier, as I drew it here, would have a negative slope. And it's going to have a negative slope. This is a basic illustration of the idea of trade-offs and opportunity cost. The slope, if you remember from algebra, the slope of any curve would be the rise over the run, or the change of the y-axis variable divided by the change in the x-axis variable. If we start here at this point where all of our resources went into the production of wheat, and we have no oranges, and now let's imagine, we're going to pull some resources out and produce some oranges. When we do that, okay, we're going to produce some number of oranges, and that's going to give us the run here on the x-axis. And we'll produce oranges, so we'll have an increase in the number of oranges. But starting from this point here, the only way we can produce oranges is to take resources out of the production of wheat. When we take resources out of the production of wheat, the amount of wheat we can produce is going to have to fall. So when we think about what would be the rise here, well, it would actually be a fall. We would be producing some oranges. We can see we would be producing some oranges, but we'd have to be giving up some bushels of wheat. When you think about it, then they're going to have a change in y that's negative and a change in x that's positive. That means a negative slope. The production possibilities frontier is going to have a negative slope, and that comes from just the very nature of opportunity costs. And again, the way we've constructed this, thinking about if we put all of our resources into producing wheat, and then think about pulling some of those resources out, we're going to have a negative slope. That's just a reflection of scarcity. We could not have a positively sloped production possibilities frontier, because that would be suggesting that when we're using all of our resources and using them to the best of our ability, we could somehow then make some change where we would get more wheat and more oranges, and so that doesn't make sense. In a world of scarcity tells us we've got to have a negative slope to this curve. Now, I drew this curve so it's bowed as opposed to being a straight line. Is there some reason for that? Well, there is, and it's related to what's known as it's the exact opportunity cost. If we were to calculate the slope of this curve between any 2 points, the slope of that curve would be the opportunity cost. So if we had a production possibilities frontier, I was trying to draw a straight line there. If we have a production possibilities frontier that's a straight line, well, we know that for a line, the slope of a line is the same at all points along that line. Okay? That's what it means for a curve to be linear. It's got the same slope at every point. If this production possibilities frontier is linear, and the slope of the production possibilities frontier is the opportunity cost, a linear production possibilities frontier would mean that we'd be having a constant opportunity cost as we move along this production possibilities frontier. I drew it so it's bowed, and when it's bowed there, what you can see is that initially the slope of this PPF is pretty flat, but then it starts getting steeper and steeper, and then down here it's quite steep. So the slope goes from being well, it's got a negative sign, and we'll leave it as it's pretty flat. So it's pretty flat here, and then pretty steep over here. That the absolute value of the slope, if you drop that nasty negative sign here, that might be causing some problem. That if you drop that negative sign, you can see that is the as we produce more oranges, the slope is getting larger. It's getting steeper. This curve is getting steeper, and that means that the opportunity cost of producing oranges is going up. And so if you have a bowed PPF, that's going to represent what's known as an increasing opportunity cost. Now, depending on the exact nature of technology, whether we would have constant opportunity cost, which would be the linear case, or a bowed PPF and increasing opportunity costs, it might be one or the other. It just sort of depends in some sense about the nature of technology. As a general rule, we can probably suggest that we must have that the increasing opportunity cost case applies most of the time. And the reason for that is that we have that many of our resources are specialized. And if you think of the case of wheat versus oranges, just think of land. Now, land in Florida is great for growing oranges. That's why it's known as, that's why you produce so much Florida orange juice, right? Florida is a great state for growing oranges. So in other words, the land in Florida, not just the land, but then also the climate, is very suited for growing oranges. Kansas is a great state for growing wheat. The land in Kansas is much more productive when you use it to try to grow wheat as opposed to growing oranges. Now, if we're going to produce wheat and nothing but wheat, we're going to have land in both Kansas and Florida planted with wheat. If we then start to take some resources out of the production of wheat and start to grow some oranges, we're undoubtedly going to start growing oranges to begin with in Florida. So we start getting some of those really nice places where you have orange groves there in Florida, and we start growing land that wasn't very good for growing wheat is very good for growing oranges. We get a lot of oranges and give up relatively little wheat. When we're going to get down to producing nothing but oranges, now we've got to plant oranges in Kansas and Montana and other places where the climate is not very suitable for it. When we take out some of that, we take out the last wheat farms down here to put all of our resources into producing oranges. We're taking those very best wheat farms in Kansas that yield huge numbers of bushels per acre, and we start planting orange trees in there. Of course, I mean, it gets very cold in Kansas, so you're not going to get a lot of oranges out of it. Probably the orange juice might not even taste very good, but you get a little bit more, you get a few more oranges, but you give up a lot of wheat. The opportunity cost of producing oranges is the amount of wheat we give up. And what we can see is that initially, because of specialization of resources, we give up very little wheat to produce oranges because we start growing oranges in Florida. But eventually, we are going to give up a lot of wheat to get just a few more oranges, and that's because you're going to be trying to grow oranges in Kansas. So we generally will draw the production possibilities frontier with this bowed shape because it's generally the case we probably have increasing opportunity costs. So that's our first graph of the class, the production possibilities frontier.